Welcome back to The Explainer. Okay, today we're strapping in for a real tech detective story. You know that feeling when you're just trying to run a totally basic, everyday command and you hit a massive wall of cryptic error text? Yeah, we've all been there, so you're going to appreciate this one. We're looking at a super fascinating case study involving a stubborn Haskell error, a broken secure connection, and the hidden complexities of modern web security. Let's get right into it. I absolutely love this quote from the developer who actually documented this whole journey. They asked, "Isn't this rather fascinating?" Honestly, when you hit a brick wall in your code, it is so incredibly easy to just get mad, right? But treating that error as a fascinating mystery instead of just a frustrating blockade is exactly the mindset we need to crack this case. So, put on your detective hats because we're tracing a seemingly inexplicable failure all the way down to the security protocols that literally run the modern web. So let's look at the setup. The goal here was super straightforward. The developer was working on a personal Haskell project and just wanted to use Hoogle. If you don't know, Hoogle is this really popular command line tool for searching Haskell libraries. To use it offline, you just run Hoogle generate to build a local database. Sounds simple enough, right? Well, whether they used the stable stack version, 05184, or pulled the absolute bleeding edge latest version from GitHub, 0519.0, the result was exactly the same. Complete and total failure. All right, let's dive into this error. Instead of downloading the config file it needs from stackage.org, Hoogle throws this massive exception, ending with this fatal line. Expecting server hello got alert level fatal decode error. Basically, it's an internal exception citing a handshake failed error. When you see something like this, it literally means the secure communication channel between the client and the server collapsed before any actual data could even be requested. Just dead on arrival. Now, if you're a developer, you probably have a knee-jerk reaction for this exact situation, right? When a local tool complains about an HTTP or secure connection error, you just slap the insecure flag on it. It's the classic workaround to bypass those pesky local certificate validation issues and just get back to work. So the developer tried exactly that, running Hoogle generate with that insecure flag. But get this, the error didn't change at all. Nothing. Zero. Which begs the question, why on earth doesn't the insecure flag solve this? To figure that out, we have to compare what the flag is supposed to do against what's actually happening. Normally, the insecure flag kicks in after a successful handshake. It tells Hoogle, hey, don't worry about checking if the server's security certificate is trusted. But the reality here? The remote server is forcefully killing the connection during the initial handshake. The connection is dead before a certificate check even happens. So the insecure flag is completely useless because we aren't even making it far enough into the conversation to actually use it. Let's break down the TLS handshake process to see exactly where things go wrong. Step 1, the client requests a connection and hands the server a list of its ciphers. That's just the cryptographic algorithms it supports. Step 2, the server evaluates that list. And step 3, well, here's our point of failure. The server terminates the session. It throws that decode error we saw earlier. Why? Because the server spotted a weak cipher in the client's request and basically just said, nope, absolutely not talking to you. Now, what's really interesting about this is the culprit hiding under Hoogle's hood. It turns out to be the default Haskell TLS library, specifically version 1.9x. This older library is packing legacy, outdated ciphers right in its standard list of supported algorithms. It's essentially walking up to a modern, highly secure server and offering to use an outdated, easily crackable code. And modern content delivery networks, or CDNs, have drastically updated their security. They only support a very strict, small set of incredibly strong ciphers now. So what does this all mean? Why are modern servers being so intensely strict? Well, it's to prevent a cipher-downgrade-attack. This is a nasty little exploit where a malicious actor intercepts the handshake and actually tricks the connection into using those weak legacy ciphers instead of the strong ones. Once downgraded, the attacker can just break the encryption. To completely shut this down, modern servers just refuse to negotiate with clients that even offer these weak ciphers. They drop the connection immediately. So to be clear, our developer isn't actually under attack here, but Hoogle is getting completely caught in the crossfire of modern server defenses. Okay, so we know the problem. The fix should be a breeze, right? Ideally, you just upgrade the TLS library to version 2, get rid of the legacy ciphers, and call it a day. But surprise, complex transitive dependency conflicts made upgrading completely impossible. Changing that one library basically broke a whole chain of other requirements in the project. So the developer had to get their hands dirty with a manual source patch. They had to go in and actually tinker with the Hoogle source code directly. It was really the only effective workaround. And this brilliantly illustrates the fix.
The developer goes into Hoogle's input/download.hs file and makes a few key changes. First, they import network.tls. Second, and this is absolutely crucial, they explicitly import ciphersuite strong from network.tls.extra.cipher. Then, they update the connection manager settings to force the use of those strong ciphers in the request. By manually restricting the client to only offer strong ciphers, the server finally accepts the handshake, the connection is established, and Hoogle Generate works like a charm.
This whole journey is just a perfect example of how a seemingly tiny dependency, an outdated library offering a weak cipher, can bring your entire modern workflow to a complete halt. And it really makes you wonder, as modern CDNs and web servers aggressively tighten up their security to fend off exploits, how much of our everyday legacy infrastructure is secretly just one handshake away from completely breaking? It's a fascinating, if maybe a little unsettling thought to leave you with today. Thanks so much for joining us for this explainer, and hey, keep questioning those cryptic errors.